So as I promised in my previous video, I am here with you with my new video on degrees of freedom. Very interesting topic. Please be with me for around 5-10 minutes. I hope I'll clear your doubt about degrees of freedom. Believe me, when I was reading about degrees of freedom in theory, it was not that easy. It took me a while to understand that, and then I try to simplify it, and I'm showing you the simplified version of degrees of freedom. Okay, in theory, if you go and read the books, the degrees of freedom is nothing but the amount of values that are free to vary in a system. So that is the definition of degrees of freedom. Okay, but if you see this, I think this will not give much clarity, right? So that's why I'm showing you with example and making this definition in a simplified in a simplified way, okay, which I'm going to present in front of you. Assume, let's start with a very simple example, okay. Assume I have four data set. Now four data set, maybe I have taken samples, assume. So first time I've taken two samples, then three samples, then five sample, and then four samples. So total, if you see here, so total I have somewhere around 14 samples, okay. And degrees of freedom is actually linked with the deviation of your data through the mean. So now here, if you see, we have total 14 samples, and the average of these sample is 3.5. Okay. So if I take a deviation from of these data points through the mean, which is here, so these are nothing but the deviations, right? So 2 minus 3.5 is minus 1.5. 3 minus 3.5 is minus 0.5. 5 minus 3.5 is 1.5. So there is a rule of deviation which says that if you have, let's say in this case, we have four data points, and if I took the deviation of these data points from their mean, the sum of all the deviations will equals to 0. You can see the sum is 0 here. Minus 1.5 minus 0.5 plus 1.5, and last will be plus 0.5. Now let's understand in a other way. By using this formula, whenever we have whatever the data point it may be, if I'm taking their deviations from the mean, and if I sum those deviations, the total will be 0 always. Okay. Now by taking this example, or by taking this understanding, let's try to do it again. So this is 2 minus 3.5, 1.5. This is 3 minus 3.5 minus 0.5. 5 minus 3.5 is 1.5. Now, if I sum this all these three numbers, it is coming as minus 0.5. So if I know that the total sum of all these four deviations is 0, right? As per the formula or as per the definition. But for these three deviation, the sum is minus 0.5. It means the last deviation number will definitely will be plus 0.5, which you can see here, right? Why? Because the sum is 0. So in other way, the last number or the last deviation number is not free to vary. Correct, because it's a fixed number. It can't be vary because the deviation of these is minus 0.5. So if last number is not free, correct, or indirect way, even I have these numbers and I know the deviations from their mean will always be 0. So this number is not free. The last number is not free to vary. And the degrees of freedom, if you see the definition, the amount of values that are free to vary in the system. So if I assume these four values is a system, and out of these four values or out of these four data point, I have the last data point which is not free to vary. So how many degrees of freedom I'll be having? This will be 3, right? Because the last number is not vary or not free to vary, correct? Now let me take you a bigger example. Suppose I have the vendor data and I have collected their delivery time. So I have close to, let me check, I think 12 data points. So 12 data points of vendor number one I have collected here. Okay, and their delivery times is right here. So I have 12 data points. In these 12 data points, the average is 92.66 something, and I took the deviation between. So here is the average. You can see here the average is here L1 92.66. So if I taken a deviation between this data point with the mean, which is L1, you can see for each data point I have taken the deviation between this data and the mean. And if I sum all these, so it should be 0, and it is 0. You can see here, right? The sum is 0. Now, in this case also, if I took the sum till here, it is coming 2. So I'm for sure that the last number will be minus 2 because the overall sum is 0. It means this last number is again not free to vary. It cannot be anything else. It should be it should be minus 2. So that's why we have degrees of freedom always as n minus 1, where n is the number of data point. So here in this case, if we have 12 data points, so degrees of freedom will be 12 minus 1 as 11, right? You can see here. So we have 12 data points for vendor number 1. This is the data points for vendor number 1, and you can count here 12, and this is the mean of all these vendors, and this is the degrees of freedom, which is 12 minus 1. Similarly, for vendor number 2, I have a vendor list here, and I'm using the same vendor list which I used in some of my video. Okay, and if you go down, you have vendor number 2 here, right? And we have for number 2 how many? 12 data point. You can see the count here, 12, right? And if we have 12 data points for vendor number 2, so degrees of freedom for this will also be 12 minus 1, which is 11. Same way for vendor number 3, we have 10 data points, degrees of freedom will be 9. And for fourth vendor, I have 11 data points and degrees of freedom will be 10. So if I add all these, so it is showing me the total degrees of freedom for all these vendors is 41. Okay. Now, what is the benefit of degrees of freedom? I hope you have seen my video, my first video on ANOVA. Okay. This ANOVA where we use F statistics, and finally the F statistics will help us to give the p-values. And finally, with the help of p-value, we will say whether our hypothesized value or whether our null hypothesis is fail or not fail to reject. Okay. So that's why these degrees of freedom are very important to calculate those p-value or f-value. Okay, I'll show you in the mini tab straight away. So let me just copy this entire data. So there are the data related with the vendors. This is my mini tab. Let me just copy and paste this data. So this is mini tab 17. You can use any other mini tab as well. Okay, just go to stat, click on ANOVA, one-way ANOVA, very simple. In the response column, you have the delivery time. In factors, you have all the 4 vendors, right? In the graph, I'm not selecting anything. For interval also, I will unselect and I will click OK. When you click OK, you will get your results in the session window, right? Now here, I will not talk about all these things. I will mostly talk about this degrees of freedom, because this degrees of freedom will help you to get this adjacent mean of square, and finally this mean square will help you to get f value, and finally this f value will give you the p value. So you cannot get this mean square without these degrees of freedom. So that's why degrees of freedom are very important when you are doing the hypothesis testing or when you are working on the statistical part. So now you can see the vendors. Total vendors we have 1, 2, 3 and 4. So 4 vendors, so degrees of freedom is 4 minus 1 is 3, right? Now coming to total first, and then I will come back to the error part. In total, you have 45 data point. Why 45 data point? You can count these number of data points. So 12 plus 12, total 24, plus 10, 34, plus 11, 45. So 45 minus 1 will be 44 degrees of freedom for total. Now, what is the meaning of error? So error is nothing but for each particular vendor degrees of freedom, and then sum of all those degrees of freedom will give you error. So for example, you have total 12 data point for vendor number 1. So degrees of freedom for vendor 1 will be 12 minus 1, 11. For second also 12 minus 1, 11. For third is 10 minus 1, 9. And for the fourth one is 11 minus 1, 10. You can also see on the Excel file, right? On the top. You can see these are the degrees of freedom. And if I add all these, it will give me 41. So this 41 you can see here, right? So this is the degrees of freedom for error. Now I've already shared my other video for sum of square. And when you divide this sum of square with the degrees of freedom, you will get this mean of square. So 61 divided by 3, 61.91 divided by 3, you will get this number. 504.89 divided by 41, you will get this number. And when you divide this 20.64, which is your vendor adjacent mean square, divided by 12.31, you will get this F value. And when you get this F value, and when you go to the F table, from this value you will get your p values. Okay, so this is how you can get the p values by using these degrees of freedom. So that is why these degrees of freedom are really important. Okay, and I hope you like this video, and I hope this simple fundas of degrees of freedom, what is degrees of freedom, how to calculate it, I hope you have cleared your doubt if you have any. Okay,